Hello everybody, and welcome to Middle Third. Today I'm introducing a new series of videos on a very beautiful and fascinating topic in mathematics, complex analysis. Complex analysis, at its core, is all about exploring the complex number system and functions that involve complex numbers. The applications of complex analysis are boundless. To name only a few, number theory, geometry, group theory, quantum mechanics, and just about every branch of engineering make use of complex analysis extensively. A word of caution about this endeavor we are about to embark on. Understanding complex analysis is a long and lengthy journey, and it requires strong mathematical maturity to understand the terminology and concepts behind what is truly going on. If you don't have experience in complex analysis, we are entering the uncharted waters of metric spaces, holomorphic functions, and residue theorems that can be difficult. But with the right captain leading the way, I think we'll be able to weather the storm. I should perhaps state what this series of videos is and what it is not. This is not an essence of complex analysis video series. This series is not a topical introduction to complex analysis, but represents a full course that would be taught at an upper undergraduate or graduate level. Secondly, the amount of videos in this series is undetermined at this point. I would expect it to be around 100, but I also expect that this series will take several years to finish, given that I most likely will redo videos that I've posted, remaster them, add things, delete things, until I'm fully satisfied that this series is the best work that I can produce. So what are the necessities for the journey that we are about to embark on? Not as much as you would expect. You should have a good understanding of calculus, single variable, and multivariate. Secondly, you should have a strong understanding of proofs. This is arguably one of the most important things to pack because this series will be entirely proof-based. Some linear algebra knowledge would be nice, but is by no means required. Additionally, some familiarity with the complex number system is also helpful, but again, it's not required. We'll start from the beginning under the assumption that you have never seen complex numbers before. Finally, you will need to have familiarity with a subject that doesn't have an agreed-upon name. Advanced calculus, foundational analysis, introductory real analysis are all names common for this subject. This subject is the rigorous explanation and derivation of calculus under the real number line, and commonly uses epsilon delta proofs to prove higher-level concepts such as continuity and convergence. If you have used epsilon delta proofs before, you are set. But if you haven't, I would suggest reading Stephen Abbott's Understanding Analysis before learning complex analysis. With that being said, that is everything I wanted to cover. Let's begin.